Solar energy is absolutely crucial to our long-term sustainability. There's no question about that. No one's doubting that. We use fossil fuels because they're easy, they're convenient right now, but there's no reason to be using that technology. We have better ways to do it.
You know, the sun goes down at night. What do you do about energy storage? So you got to figure out some way to use the sun during the day, and that's where the biggest part of our effort is, so-called solar fuels. So that you make fuels like natural gas, if you could do it, and oxygen, you burn those at night. And that's kind of the basis for the research program at UNC.
So what we're trying to do is get away from burning fossil fuels and go towards utilizing the sun for energy. That's our most fundamental energy process on the planet, is absorbing sunlight, making plants, making fuels from that energy.
From the scientific challenges that we face today, no doubt energy is one of them, if not the most important one, that has large implications for society as it is right now.
So when you're talking about turning sunlight into fuels, basically the fundamental process there is absorbing sunlight. Well, what happens when molecules absorb light? And that's what I do. That's what all of us do in the laser lab downstairs, is we hit samples with light and try to understand what sort of processes go on. If you understand the processes, you can easily manipulate them towards your end in terms of what goals you have. Understand first, manipulate later.
As a graduate student here, I do a lot of research, playing with different concepts and ideas, and in chemistry down at molecular level. I do a lot of synthetic work, so seeing what may or may not work in the future and screening for options.
As an Energy Frontier Research Center, we're expected to push the limits of science. That's our job. We encourage and expect people to work across disciplines on these grand energy challenges. It's the only way that any of the EFRCs will be making major breakthroughs.
Now we're making real progress. We have this integrated effort, and that's really key. We have people from different institutions and from physics and chemistry and material science. We've learned how to do things like water oxidation, which is a really important part of our solar fuels effort. People just didn't know how to do that very well. We think we're making real progress on that front. We're also making a lot of progress on how to put all this together. Because if you want to, in fact, do the solar fuels in the way we want to do it, we need to work out the different pieces of the puzzle and then integrate them. And that's really what we're up to.
So when I come to work every day, my biggest concern is that somebody's going to solve the world's problems before I do. And that's absolutely the most fun I could have working in an institution.